Okay, so this is our normal curve. This is how, when we have data that says it's normalized, it follows this pattern, which is called a bell curve or a normal curve. And what that means is right in the middle we have our mean value, or the average, whatever you want to call it. And this number is the one that shows up the most. It's the most frequent. And from there, our values or our scores or whatever they are goes out, and it follows this pattern. And these numbers at the bottom that go by 0.5 represent standard deviations. Standard deviation is a measure of how far the data is from the mean value. On a normal curve, between the average and one standard deviation away from the average, you're going to have 34.1% of the data. Same thing going below. One standard deviation below the mean, you'll have 34.1%. This curve is symmetric, so everything on the right repeats on the left. Two standard deviations, well, now you're going to add on another 13.6%, and three standard deviations, you're going to add on another 2.2%. If you add up all the percentages on this curve, it adds up to 100% of the data. If we look at this, if we have data that's outside of three standard deviations from the mean, that happens 0.1%. Really a total of 0.2%, because you could either be above or below. So what kind of questions can we get? Well, when we have a question that says the distribution of heights is approximately normal, that means we can draw what we call our normal curve. So I just sketch a basic normal curve, a straight line, and then make it that shape. I put the average or mean right in the middle, and then it tells us the standard deviation. So add 2.5 to the right, we get 71.5 is one standard deviation above. Add another 2.5, we get 74 is two standard deviations above. We subtract the 2.5 and subtract another 2.5 to get the standard deviations below. 34.1% of adult American men will measure between 69 and 71.5 inches tall. 13.6% should be between 71.5 and 74 inches tall. And then we go the other way, 34.1% will also be between 66.5 and 69 inches tall. So what kind of questions do we get? Well, the first one, what percent of men are taller than 74 inches? So we go to our normal curve, we see where our 74 inches is. It's two standard deviations above the mean. So if I go back to the curve up here, all I do is, we want taller than this, so we want to the right. Add up the percentages to the right. And when we add the 1.7, 0.5, and 0.1, we get 2.3%, because it's two standard deviations above the mean. So we add the percents that are above the two on the curve. Part B, between what heights do the middle 95% of men fall? One thing to remember is that 95% of the data is between -2 and +2, or between two standard deviations below and two standard deviations above the mean. So if we want to know between what heights do the middle 95% of the men fall, well, that's those values in there. If we add up those percentages, it gives us 95.4, basically 95%. So that's from -2 standard deviations to +2 standard deviations on the curve. So we go back to the curve that we drew. The -2 is at 64, the +2 is at 74. So 95% of the men are between 64 and 74 inches tall. Part C, what percent are shorter than 66.5 inches? So we go to our curve, which we drew. 66.5 is one standard deviation below the mean. So we add up the percentages below or to the left of that one standard deviation below the mean. So we add all these percentages over here. So we add up the 9.2, 4.4, 1.7, 0.5.1, and we get 15.9%. So that's telling us that 15.9% of men are shorter than 66.5 inches. The last question, the last part of this question, a height of 71.5 inches corresponds to what percentile of adult male American heights? Percentile is you find where you are on the curve and you add up all the percents till you get to where you are. So 71.5, if we look at this, is 1 standard deviation above the mean. So we have to add up all those percentages to the left of the 1 standard deviation. So there's our 0.1, 0.5, 1.7, 4.4, et cetera, et cetera, et cetera. Add them all up, and it gives us 84.1, which says we're at about the 84th percentile. If we go to the next page, okay, practicing different kinds of questions. Average healing time. Let me make this so you can see this one. Okay. The average healing time of a certain type of incision is 240 hours with a standard deviation of 20 hours. So here's our normal curve. 240 is the mean, standard deviation is 20, so we add 20 and subtract 20. I like to put the first and second standard deviations away and put the percentages in there. So now this question, if the hospital has treated 2,000 patients having this type of incision, how many healed in each of the following intervals? So how many healed between 220 and 260 hours? Well, 220 is 1 standard deviation below the mean, 260 is 1 standard deviation above. So we want to know how many patients. In order to find how many patients, first we have to find what percent. So we add up the percents from our normal curve, and it gives us 68.2%. Then to find how many, we change our percent to a decimal and then multiply by the total number of patients. So 68.2 becomes 0.682, move the decimal 2 places to the left or divide by 100, and then multiply that number by the 2,000 patients, and we get 1,364 that healed in that number of hours. 200 to 280, well, that's minus 2 standard deviations to plus 2 standard deviations. So again, we take those percents from our normal curve, add them up, get 95.4, change the 95.4 to a decimal, make it 0.954 times 2,000, and get 1,908. The last one, 180 to 300, is from 3 standard deviations below to 3 standard deviations above. We have 2 ways of figuring out this percent. We could say, well, really that's just the 100% minus the 2 little percentages at the end minus the 0.2, or we could add everything up except those 2 little percentages at the end, and we get 99.8%. To find the number, we do 99.8 as a decimal times 2,000, gives us 1,996 patients. Okay, problem 3. We have the mean is 12 and the standard deviation is 1.5. So here's our curve. Mean is 12. Add 1.5, subtract 1.5 to get our values. And now we know, first question, name the interval about the mean in which about 68.2% lies. So if we put our percentages in there, we see that 34.1 plus 34.1 is 68.2. And what 2 values is that in between? That's from 1 below to 1 above, or from 10.5 to 13.5. The next question, what percent goes from 7.5, 3 standard deviations below, to 16.5, which is 3 standard deviations above the mean? So again, we do what we did in the last part of the question above. We add up all the percentages except the 2.1s on each end, and we get 99.8%. Last question, find the percent of 9 to 15. So again, 9 is 2 standard deviations below, 15 is 2 standard deviations above. We just add all the percents in there, add them all up, we get 95.4%. Now to look at just certain questions on here, let's see. For number 4, well, here's the work for each of them. I'll scan these and put them on Canvas, although it's already up there. So let's look at number 4. In a normal distribution, x bar is the mean, sigma is the standard deviation. If we have one equation where x bar plus a half a sigma is 100, And another one where x bar minus a half a sigma is 80, what's the mean? X bar and sigma are kind of like x and y, so we just set up a system of equations, and when we set it up, we can use elimination because the sigmas cancel out, plus 0.5 minus 0.5 cancels out. So we wind up with 2x bars equals 180. So x bar, which is the mean, equals 90. Okay, so that question was a little bit different. The national sit-up test, normal distribution, the mean was 42 sit-ups per minute, standard deviation was 2.6, which could be expected to occur less than 5% of the time. If we look at our normal curve, less than 5% is when we're on the outside, when we're like more than 2 standard deviations away from the mean. So again, here's our normal curve, 42, go up a couple standard deviations, go down a couple standard deviations. Which one of these choices is outside of those values we have written? 50. So this was just a quick kind of overview of how to do standard deviation questions. Practice the other ones and then do the problematic assignment.